All righty. All righty. Let's hope the audio is working. I had a little trouble a moment ago. Jim Ballinger, NMH. Thought I'd do a quick unit on quadratics. Purpose of the video is to be able to identify a whole bunch of information very quickly. Quite frankly, there's never a need for the quadratic formula. Shortcuts here. You can do things in 30 seconds or less and pretty much know anything about any quadratic coming your way. Take a little practice, obviously. I'll start with an easy one, go to a much harder one, and then back off again for a third attempt at looking at what information you can glean from just looking at the calculation. All right, so I'm going to keep rolling along here, but the object of this is take about 30 to 60 seconds and look at this. So pause the video, take about 30 to 60 seconds and tell me everything you know about the quadratic you're looking at. And then we'll put it in the ax squared plus bx plus c form and go through the same process. All right, so pause the video, 30 to 60 seconds, tell me everything you know. I'm just going to rattle off what I know now. Okay, all right, so the first thing I see, y-intercept, 0, -8. I can see that at that instant, it's going down at a 2-to-1 ratio. I can see that the roots here obviously are -2 and +4, and we'll get those a different way in a little bit. So knowing that, I can say that 1 is the axis of symmetry. And plugging in a 1 gets me -9. So 1, -9 is the vertex. And now I know, using where the quadratic formula comes from, my roots are x equals 1 plus or minus the square root of +9/1. Okay? And you can check that plus or minus 3, 1 plus 3, there's your 4, 1 minus 3, there's your -2. That's pretty much all you need to know in terms of mechanics. So let's put this now in the ax squared plus bx plus c format. So you got x squared. I'm going to write the number 1 in front of that. It's going to come into play. Minus 2x minus 8. All right. That looks awkward. Let's get it out of here. Remember that that's a 1. All right. So we're looking at this, and we're going to go through the same format again. All right. But I think I'll take you through it right now. You don't pause. If you want to, you can. All right. But can you see where -8 is? Let's get rid of that. Oh, so that's the y-intercept of a quadratic. Looks like we can get that anytime, right? The rate of change at that instant is -2. So here we are at 0, -8, and I'm going down at about 2-to-1. All right. Oh, geez. You know, we'll look at in class why we know that. We don't need calculus for that. We'll just play around with that in class, maybe at the end of the video, depending on how long this takes. Got about 15 minutes to do this, so let's see how that works. So that's really quick to get. I think we know it's cup shape up. So therefore, vertex is here. Of course, you've got to be able to find that x value quickly. And we said it's 1. Geez, minus b over 2 times a. 2 divided by 2 is 1. I guess there's a quick way to get the x value of the vertex. And this is -2. Let's show you the shortcut for finding the vertex. So 1 squared is 1, -2 minus 8. Curious minds might want to look at the relationship between those two terms, those two evaluations. Twice the size of that and opposite. You will find, I'd like you to take a year or two to see that pattern for yourself, but we're going to march through a lot of different topics, so I'm spelling it out for you. But you will always get a 2-to-1 ratio here with an opposite value for each, one positive, one negative. Okay, so you plug in a 1. 1 minus 2 is -1 minus 8. Well, that's not hard to get that. And so now the issue is, from this location, how do we get to 0? How do we get up here to a height of 0? Well, we got to move 9 units from there, right, in this whole process. So starting at 1, you got to go that direction, which is the positive. You got to go in that direction, which is the negative, to get to each of these roots. And it turns out that it's the square root of whatever that distance is divided by the coefficient of the x squared term. There you have it. Get all your roots, you get your vertex, so on and so forth. So if you were going to graph this, you might have started at -8, gone down, come back up again, minus b over 2a, evaluate it in the calculation. You got your y value, change the sign of that. Well, I've got another one that I did out because I wanted to take the answers, the roots, plug them in to show you that they work. And that I wanted to do on the other side of the board so I didn't waste your time. I'll take you through it. Okay, so the one I picked at random, let me find my eraser here. I said I wouldn't, I'd always put it in the same place. Of course I haven't. So gotta go find it. I got it, coming back. All right, so we're gonna do a more difficult one, but honestly, I think you can get all this information in 60 seconds with a little practice, especially with that shortcut, the 2-to-1 ratio of the first two terms when evaluated. All right, so I picked, what did I pick? I picked y equals 3x squared minus 4x plus 5. Just for obvious reasons, a little mnemonic device. Yeah, person, woman, man, camera, TV. Little mnemonic device there, so I could remember 5 words. Yeah, people are men and women in front of the camera for TV. Yes, that helped me. I remember that better now. Okay, so what do we have here? I'm sorry, should be talking politics. Y equals 3x squared minus 4x plus 5. Oh yeah, so you're gonna pause the video. You're gonna do 60 seconds. I'm gonna rattle it off. So what do I see? I see a y-intercept of 5. I see that I'm moving down at a 4-to-1 ratio at that y-intercept. I see cup shape up. So therefore I'm at 5, I'm moving down, cup shape up. The real issue is, where am I bottoming out? So I gotta find that. How do I find that? I gotta find the x value. Minus b over 2a, which is 4/6, we'll call it 2/3. And now here comes the shortcut. So I'm gonna multiply 2/3 times -4, which is minus 8/3. I'm gonna cut it in half, which is minus 4/3, and I'm gonna add 15/3. That's why we do so much fraction practice in class. Okay, that's minus 11, that's positive 11/3. All right, so there we have it. And that is 11/3 for a y value. So how am I gonna get to 0? Looks like I got imaginary roots this time. All right, well, here's the process. So, well, I already got the vertex here. I should include that. So 2/3 is the center. So my roots are 2/3 plus or minus the square root of this distance. It's negative now, right? Because it's positive here. Got to go down. Negative 11/3 divided by 3, which is minus 11/9. And we're going to take that negative sign out, and we're going to call this, we're imagining things. Okay, so I think I got everything. I got my roots, got my vertex, got my rates of change, which helps me think about topics coming later. Great pre-calculus topic. Y-intercept. I think we're cooking with gas. All right, so I said I would take this and I would check it out. All right, so I took my time with that because I didn't want to make any mistakes. And we won't do that. I'm not going to ask you to do that too often, but just see if you can follow along for a second. All right, so there's our vertex. Here's our equation. We're setting it to 0. So the first thing I got to do is take one of my roots. I'll take the right-hand root. Ooh, that, okay, looks like we got quite a, the light shining here is giving a reflection. All right, but we're beyond that now. So this was 3x squared minus 4x plus 5. That's what's blurred out. And now I'm going to take my right-hand root, which is imaginary, and we're going to find it to see if this works. So I got to square this first. Got to take this root and square it. Then I got to triple it. Minus 4 times that root, add 5, see if it comes out to 0. So I squared it. We practiced that. 2/3, 4/9, double the product. So that's 4/3 times the square root of 11 over 9. And, sorry, I forgot the imaginary. Put the imaginary here. And then where was I? Oh, then we square this. And that gives me 11/9. I squared. What's I squared? -1. So it's minus 11/9. I've got to triple that. And then I'm going to multiply this by 4, negative 4, excuse me, negative 4. So minus 8/3 is right there. Minus 4 root 11 over 9I. Notice I didn't rewrite this as square root 11 over 3. I thought it was easier just to leave it as is because it's going to cancel anyway. And plus 5. So the next step, multiplying by 3 gets me 4/3. 3 goes into 9, right? 4/3. 3 times 4 is 12 over 3, which is 4 times the square root of 11 over 9I. And then I got minus, 3 into 9. So minus 11/3, yep. Minus 8/3 minus 4 times 11 over 9, square root of 11 over 9I plus 5. So these cancel. Oh, that's so nice. These do cancel. And I got minus 11 minus 8 is minus 19 over 3. Remember, 5 is 15 over 3. 15 over 3 plus 4 over 3 is 19 over 3. And 19 over 3 minus 19 over 3 does get me 0. So it's a correct root. I never use a quadratic formula. I mean, I just bang them out like that. More times than not, they're simpler than that anyway. Some useful information. You know, you really can tell quickly whether something's rational or irrational, imaginary. Okay, I mean, you'd use it to discriminate too. B squared minus 4AC is inside the square root. So, you know, that's what that is. So if you have an SAT question or something, I don't know where you might see that in what context, but certainly textbook problems. All right, so I said I'd give you one that was kind of in the middle of level of difficulty. So I thought I'd pick the problem I use in my calculus classes. Around midterm, we finished all work with integrals and derivatives. And so I like to have everybody put every concept that we've practiced for the year in one problem. All right, so I'm going to take a ball, a soccer ball, not that I can kick it anymore, I can't. Maybe again, I'm hoping the hip comes back. So I kick it straight up in the air. Nice technique, no rotation on the ball. It left my foot when it was 3 feet high. 2 seconds later, it's 67 feet. Then it starts to come back down. Okay, so this is what I do in the calculus class, and I have to teach that class something about how to write that equation from the get-go, which I hope we have done already in our class by the time you see this. But if you haven't, well, you can learn the process. So this is what we're looking at. We got a time to height as a function of time. Looks something like this. It was 3 feet high. I kicked it. I put force on the ball. Went up to 67 feet after 2 seconds. 267, and it started at 0.3. All right, so we've practiced this, right? 67 minus 3, 64, down 64 feet. 2 squared is 4. Vertex, x minus 2 squared plus 67. Okay, all right. That actually turns out to be h of t equals minus 16t squared. I mean, I can this problem, right? Plus 64t plus 3. Now, tell me what you know. Pause the video, do the same thing, bang. Okay, I'm just going to bang it out right now. So, y-intercept 0.3. Going up at that instant, up 64 feet per second. That was the force I put on the ball, by the way. And it went up into space. Oh, no, it didn't go up into space. Gravity brought it down. We're talking gravity right here in feet. Forgive me, I haven't had a physics class, so can't talk to you in meters. It's all right. I got some more time. I can maybe learn that. All right. I got a lot of good colleagues in the science department. Maybe I should go have a little chat. Probably should. Where was I? Oh, yeah. So now we got to find that this is a cup shape down. So we got to find that x value. How do we find it? Minus b over 2a. Minus 64 over minus 32. Oh, yeah, that's 2. And then what do? We drop it in. Cut this in half right now. 32 times 2 is 64 plus 3 is 67. Oh, yeah, it all matches up from what we said it would. And so then what do I do next? Well, I got to go down 67 feet to hit the ground, right? Because I kicked it 3 feet above the ground. So when does it hit the ground on the right side? Well, according to this model, that value, that x value, is 2 plus the square root of 67 over, I've got to multiply this by, I got to divide this by, so I got to go down 67, excuse me, and I got to divide by minus 16. Okay, now it would come back to 3 feet at 4 seconds. right? The symmetry of the quadratic. So it's going to hit the ground just a little bit later. So let me change this into the square root of 64 over 16. How many times is 16 going to 64? If you said 4, you would be right. You would be right. And what is 2 plus the square root of 4? That's this number, right? But we have something just a little bit bigger than 4. I don't know what the decimal is, but that's the extra time it takes to hit the ground. Now, I think I got a lot out of that quadratic, not much work, all right? And the rule in our class is if we find an easier, softer, simpler way, we adopt it. Now, it's going to take you a little practice, but I'll give it to you. I'll bet you within a week's time, a lot of you just going to be able to, in 60 seconds, nail every aspect of this quadratic. There's more, why this works. We'll get into the geometric aspects of that during the course of the term, maybe make a video on it. I'm getting on a roll making videos now that I know how. So I'm going to upload this. You can watch it again. I'm sure I'm going to be rolling it out from time to time because I like repetition. So you see it now, maybe a week from now you watch it again. Another week you watch it again. I think it's a way that you'll put it in your long-term memory. Okay, sorry for that reflection right there. I'll have to work on that. But right now I'm going to upload this and post it. All right, take care, everybody.